Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about Part 4, Geotechnical Engineering, Soil, Question and Answer. 1. State the assumptions made in Coulomb's theory. The backfill is dry, cohesionless, homogeneous, isotropic, and elastically undeformable but breakable. The slip surface is plane which passes through the heel of the wall. The sliding wedge itself acts as a rigid body and the value of earth pressure is obtained by considering the limiting equilibrium of the sliding wedge as a whole. The position and direction of the resultant earth pressure are known. 2. Compare Rankin's and Coulomb's theory. Rankin's theory, Coulomb's theory. The intensity of earth pressure at each depth is known. So point of application of the earth pressure is known at any depth. Only the total earth pressure value acting on the retaining structures can be calculated. The point of application of earth pressure can be calculated from Coulomb's assumption that all points on the back of the retaining wall are essentially considered as feet of failure surface. Wall is smooth and vertical. Wall is rough and sloped. Wall moved sufficiently so soil is in plastic failure mass. Wall is rigid, straight failure plane and rigid failure wedge. 3. Define Coulomb theory. Write the Coulomb's equations to account for wall friction. Coulomb, in 1776, developed an earth pressure theory which includes the effect of friction between the backfill and the wall. The theory considers a dry, non-cohesive inclined backfill, and the lateral earth pressure required to maintain the equilibrium of a sliding wedge with a plane slip surface is calculated. 4. What are the points to consider Coulomb case with no soil wall friction? For the Coulomb case with no soil wall friction, i.e. d equals 0, and a horizontal backfill surface, both the Coulomb and Rankin method yield equal results. As the soil friction angle F increases, i.e. soil becomes stronger, the active pressure coefficient decreases, resulting in a decrease in the active force while the passive pressure coefficient increases, resulting in an increase in the passive force. 5. What are the limitations of Terzaghi's analysis? The theory is applicable to shallow foundations. As the soil compresses, increases which is not considered. Hence fully plastic zone may not develop at the assumed. All points need not experience limit equilibrium condition at different loads. Method of superstition is not acceptable in plastic conditions as the ground is near failure zone. 6. What is depth of tension crack? The tensile stress decreases with an increase in depth, and it becomes zero at a depth z, given by equals 2, 10, equals 2, v. The depth is known as the depth of tension crack. 7. What do you understand by the term coefficient of earth pressure at rest? When the retaining wall is at rest, then the ratio between the lateral earth pressure and the vertical pressure is called the coefficient of the earth pressure at rest. 0 equals h. 8. What are the different types of earth pressure? There are 3 types of earth pressures on the basis of the movement of the wall. Earth pressure at rest. Active earth pressure. Passive earth pressure. 9. Define lateral earth pressure. Lateral earth pressure is the pressure that soil exerts in the horizontal direction. The lateral earth pressure is important because it affects the consolidation behavior and strength of the soil, and because it is considered in the design of geotechnical engineering structures such as retaining walls, basements, tunnels, deep foundations and braced excavations. Define passive earth pressure. When the wall moves towards the backfill, there is an increase in the pressure on the wall, and this increase continues until a maximum value is reaches, after which there is no increase in the pressure and the value will become constant. This kind of pressure is known as passive earth pressure. Define active earth pressure. When the wall moves away from the backfill, there is a decrease in the pressure on the wall, and this decrease continues until a minimum value is reaches, after which there is no reduction in the pressure and the value will become constant. This kind of pressure is known as active earth pressure. Define earth pressure. It is the lateral pressure exerted by a soil mass against an earth retaining structure, or on a fictitious vertical plane located within a soil mass. What is a sheet pile wall? A sheet pile wall consists of a series of sheet piles driven side by side into the ground, thus forming a continuous vertical wall for the purpose of retaining an earth bank. They are commonly used for waterfront structures, temporary construction, and lightweight construction where subsoil is poor for supporting a retaining wall. What are the other forces acting on the wall? Other forces acting on the wall aside from the earth pressure force acting on the wall, other forces might also act on the wall, and these are superimposed onto the earth pressure force. For example, these forces might include surcharge load, earthquake load, water pressure. What do you understand by plastic equilibrium of soils? A body of soil is said to be in plastic equilibrium if every point of it is on the verge of failure. Why retaining walls are usually designed for active pressure. From Rankin's assumption, no existence of frictional forces at the wall face. The resultant pressure must be parallel to the surface of the backfill. The existence of the friction makes the resultant pressure inclined to the normal to the wall at an angle that approaches the friction angle between the soil and the wall. Define foundation. A foundation is that part of the structure which is in direct contact with and transmits loads to the ground. Define shallow foundation. According to Terzaghi, a foundation is shallow if its depth is equal to or less than its width. It can be adopted for the light structures and the soil having high bearing capacity. Define deep foundation. According to Terzaghi, foundation is deep if its depth is equal to or greater than its width. It can be adopted for the multi-story building. Define floating foundation. It is defined as a foundation in which the weight of the building is approximately equal to the full weight of the soil including water excavated from the site of the building. In which situation is raft foundation is used. Raft foundation is adopted for medium-heavy structures where the soil is having low bearing capacity. Raft foundation is used to reduce settlement above highly compressible soils, by making the weight of structure and raft approximately equal to the weight of the soil excavated. Where do you use mat foundation? It is used when the area of isolated footing is more than 50% of whole area or the soil bearing capacity is very poor. When the allowable soil pressure is low, or the building loads are heavy, the use of spread footings would cover more than 1/2 of the area and it may prove more economical to use mat or raft foundation. When trapezoidal combined footings are provided. When the projection parallel to the length of the footing is restricted on both the sides. When the length of the footing is restricted. Where do you use mat foundation? It is used when the area of isolated footing is more than 50% of whole area or the soil bearing capacity is very poor. When the allowable soil pressure is low, or the building loads are heavy, the use of spread footings would cover more than 1/2 of the area and it may prove more economical to use mat or raft foundation. When trapezoidal combined footings are provided. When the projection parallel to the length of the footing is restricted on both the sides. When the length of the footing is restricted. Under what circumstances, a strap footing is adopted? When the distance between the two columns is so great, so that trapezoidal footing is very narrow and so it is uneconomical. It transfers the heavy load of one column to other column. What is the function of strap beam in a strap footing? The strap connects the two isolated footings such that they behave as one unit. The strap simply acts as a connecting beam. What is meant by foundation soil? It is the upper part of the earth mass carrying the load of the structure. Sketch the contact pressure distribution diagram for a rigid footing on sand and clay. What are the three components of total settlement of footings? Immediate elastic settlement, consolidation settlement, settlement due to secondary consolidation. Define immediate settlement. Immediate or elastic settlement takes place immediately after the construction of the structure. It is also known as the distortion settlement, as it is due to distortions within the foundation soil. Define consolidation settlement. This component of settlement occurs due to gradual expulsion of water from the voids of soil. This component is determined using Terzaghi's theory of consolidation. Define footing. A footing is a portion of the foundation of a structure that transmits loads directly to the soil. Define spread footing. A spread footing or simply footing is a type of shallow foundation used to transmit the load of an isolated column, or that of a wall to the subsoil. This is most common type of foundation. The base of the column or wall is enlarged or spread to provide individual support for the load. What is a mat foundation? It is a combined footing that covers the entire area beneath a structure and supports all the walls and columns. List the various factors affecting the bearing capacity of soil. Nature of soil and its physical and engineering properties. Nature of the foundation and other details such as the size, shape, depth below the ground surface and rigidity of the structure. Total and differential settlements that the structure can withstand without functional failure. Location of the groundwater table relative to the level of the foundation. Initial stresses, if any. A footing was designed based on ultimate bearing capacity arrived for the condition of water table at the ground surface. If there is a chance for rise in water level much above the ground level, do you expect any change in the bearing capacity? Why? The rise in water level above the ground level would not change the bearing capacity of the soil. Because the soil under submerged condition when the water reaches the ground surface. Therefore the water above the ground level does not affect the unit weight of soil. What is the effect of rise of water table on the bearing capacity and the settlement of a footing on sand? The pressure of water affects the unit weight of soil. Hence bearing capacity is affected due to the effect of water table. For practical purpose it is more sensitive when the water table rises above depth 1-3 m from footing. Define general shear failure. General shear failure results in a clearly defined plastic yield slip surface beneath the footing and spreads out one or both sides, eventually to the ground surface. Failure is sudden and will often be accompanied by severe tilting, generally associated with heaving. This type of failure occurs in dense sand or stiff clay. Define local shear failure. Local shear failure results in considerable vertical displacement prior to the development of noticeable shear planes. These shear planes do not generally extend to the soil surface, but some adjacent bulging may be observed, but little tilting of the structure results. This shear failure occurs for loose sand and soft clay. Define punching shear failure. Punching shear failure occurs where there is relatively high compression of soil under the footing, accompanied by shearing in the vertical direction around the edges of the footing. Punching shear may occur in relatively loose sand with relative density less than 35%. What is proportioning of footing? Proportioning of footing is defined as the arrangement of footing in the combined footing system, in which it is arranged in such a way that the centroid of the area in contact with the soil lies on the line of action of resultant of the loads. What is meant by stabilization? Stabilization, in a broad sense, incorporates the various methods employed for modifying the properties of a soil to improve its engineering performance. Stabilization is being used for a variety of engineering works, the most common application being in the construction of road and airfield pavements, where the main objective is to increase the strength or stability of soil and to reduce the construction cost by making best use of the locally available materials. What are the advantages of lime stabilization? Soil becomes more workable. Strength is generally improved. Lime stabilization increases the compressive strength sometimes as high as 60 times. It is effective for soils. What are the disadvantages of lime stabilization? Lime is produced by burning of limestone in kilns, so that it is harmful for environment. It needs more cost to burn limestone. It is not effective for sandy soils. There is limited percentage of amount of lime required, about 2 to 10% of the soil. Write about bearing capacity of square and circular footings. If the soil support of a continuous footing yields due to the imposed loads on the footings, all the soil particles move parallel to the plane which is perpendicular to the center line of the footing. Therefore, the problem of computing the bearing capacity of such footing is a plane strain deformation problem. On the other hand, if the soil support of the square and circular footing yields, the soil particles move in the radial and not in parallel planes. Terzaghi has proposed certain shape factors to take care of the effect of the shape on the bearing capacity. What is stone column? Stone columns refer to columns of compacted, gravel-size stone particles constructed vertically in the ground to improve the performance of soft or loose soils. The stone can be compacted with impact methods, such as with a falling weight or an impact compactor, or with a vibrofloat, the more common method. The method is used to increase bearing capacity, reduce foundation settlements, improve slope stability, reduce seismic subsidence, reduce lateral spreading and liquefaction potential, permit construction on loose soft fills, and pre-collapse sinkholes prior to construction in karst regions. Define gross pressure intensity. The gross pressure intensity Q is the total pressure at the base of the footing due to the weight of the superstructure, self-weight of the footing, and the weight of the earth fill, if any. What is net pressure intensity? It is defined as the excess pressure, or the difference in intensities of the gross pressure after the construction of the structure and the original overburden pressure. Where is the average unit weight of soil above the foundation base? What is ultimate bearing capacity? The ultimate bearing capacity is defined as the minimum gross pressure intensity at the base of the foundation at which the soil fails in shear. It is denoted by the symbol QF. Define net ultimate bearing capacity. It is the minimum net pressure intensity causing shear failure of soil. The ultimate bearing capacity QF and the net ultimate capacity are evidently connected by the following relation, where S is the effective surcharge at the base level of the foundation. Define safe bearing capacity. What is safe bearing pressure? The maximum pressure which the soil can carry safely without risk of shear failure is called the safe bearing capacity. It is equal to the net safe bearing capacity plus original overburden pressure. Equals, plus, equals, slash, plus. Sometimes, the safe bearing capacity is also referred to as the ultimate bearing capacity QF divided by a shape factor F. Safe bearing pressure. It is the intensity of loading that will cause a permissible settlement or specified settlement for the structure. It is also called as net soil pressure. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.